Okay, today we're going to talk about synthetic division. Synthetic division has a lot in common with synthetic substitution. I'm going to kind of be going quickly through those portions, so if you need a refresher on synthetic substitution, go ahead and stop this video and take a look at that one to get an idea of what I'm doing. First, let's talk about the differences between synthetic substitution and synthetic division. First, I want you to realize that when we have synthetic substitution, it's because we have a function and we have a 2 being plugged into our function, meaning that it's going into each of these x's. In division, we see a division sign with no f of x symbol. There's also parentheses showing us exactly what is the numerator and what is the denominator of our division. Let's go ahead and set up synthetic substitution. We now know that the 2 goes on the outside, and then we list the coefficients. 2, 1, negative 13, and 6. We drop down the 2. 2 times 2 is 4. 4 plus 1 is 5. 2 times 5 is 10. Negative 13 plus 10 is negative 3. 2 times negative 3 is negative 6. And that equals 0. When we end up with the 0 at the end, this is actually our answer in synthetic substitution. So f plugged in 2 is equal to 0. This is our final answer when we're doing synthetic substitution. Now let's take a look at synthetic division. Synthetic division works very similar. One thing you need to know before you start writing any numbers is that this piece right here is really an x minus a k because of that minus sign right there in the center. Because of this minus sign in the center, anything in here is really the opposite sign. So right now I have a minus 2, so I'm going to be using plus 2. And so if I had say a plus 3, then I'd be doing a negative 3. So just remember to switch those signs. So, like I said, it says minus 2. So we are going to use positive 2. Go ahead and list the coefficients again. 2, 1, negative 13, 6. Notice that the coefficients are the same as in synthetic substitution because I'm using a very similar expression. Drop the 2. 2 times 2 is 4. 4 plus 1 is 5. 2 times 5 is 10. Negative 13 plus 10 is negative 3. 2 times negative 3 is negative 6, and that equals 0. We end up with the same exact numbers at this point, but I'm not looking for an actual final number for division. Remember, long division, we're just trying to make that expression smaller, simpler, a lower degree, a lower power than the power of 3 that I see in it. So what these numbers really mean is the 0 is actually your remainder. The negative 3 is your number without an x next to it. Your 5 is the coefficient for the x, power of 1, and your 2 is for the power of 2. So the way that we write this out is 2x squared plus 5x minus 3. Since there's no remainder, this is actually my answer. See the difference between this answer and the synthetic substitution? So in synthetic substitution, we get an actual number, 0. For synthetic division, we end up with an expression, a simpler expression. Notice the power of 2 versus the power of 3 in the beginning problem. Another important thing to know is that when you have a 0 for the remainder, it means something special for what you divided by. We were dividing by x minus 2. So since we have a remainder of 0, then it's called a factor. So when you have 0 remainder, then the x minus 2 is a factor. And that's the most important statement there. X minus 2 is a factor. If I divide it by something else, say x plus 6, and I still got a remainder of 0, then x plus 6 is a factor. If I had done this problem and my remainder was, say, like a 3, well, then the x minus 2 that I divided by would not be a factor because I had a remainder. Being a factor is another way of saying going evenly, having no remainder. Let's take a look at this problem. Very similar. Let's set up our synthetic little box guy. Remember that since this says plus, it's really -1. So we put -1 on the outside. List the coefficients. 1 in front of power 3, 4 in front of power 2, 1 in front of power 1, and the -6. Drop down the 1. -1 times 1 is -1. 4 times -1 is 3. -1 times 3 is -3. 1 plus -3 is -2. -1 times -2 is 2. And -6 plus 2 is -4. So remember, always start over on the right. That's our remainder. Then our normal number, our constant, then our x, then our x squared. If we had more numbers, we would keep going up, x power 3, x power 4, x power 5, whatever fills up all the numbers I get. Now it's time to write this out. So x power 2 has a 1, so we can just write x power 2 plus a positive 3 next to our x minus our 2, and now it's time for our remainder. Our remainder has a negative, so I'm putting minus. Now it's time to make the fraction. 4 over what we divided by, which is x plus 1. Okay? So remainder is built by using the 4 and using what we divided by. And this is our answer. One more problem. So I noticed right off the bat in this problem that I don't actually have all the powers. I have 4, I have 2, and I have 27. I don't actually have our power 3 or our power 1. So first thing we should look at is that x minus 3 is really positive 3, not negative 3. So let's set up the synthetic guy. Remember I said we're going to use positive 3. Now let's list the coefficients. 2 is front of power 4. I don't see power 3, so I put 0. Negative 21 is in front of power 2. I don't see power 1, or just the x. And then the 27. Bring down the 2. 2 times 2 is 6. 6 plus 0 is 6. 3 times 6 is 18. Negative 21 times 18 is negative 3. 3 times negative 3 is negative 9. 0 plus negative 9 is still negative 9. And 3 times negative 9 is negative 27. And that gives me a 0. Going from the right, this is my remainder. This is my normal number. This is my power of 1x. This is my power of 2x. And this is my power of 3x. So now I'm going to go ahead and start to construct this. I have a 2 in front of my x cubed. I have a positive 6 in front of my x squared. I have a negative 3 in front of my x, and I have a negative 9. Since I have no remainder, I don't write anything, and this is like this. And on top of this, we now know that x minus 3 is a factor because the remainder equals 0. Okay, I hope this covers synthetic division. If you have any questions, leave a comment, and I'll see you back in class.